Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 76 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons, and in this class we will be using the Elite Explorer Kit. Now, most of you guys probably already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 75. So I must first ask, how many of you were successful? If you got the homework done, leave a comment down below. I am legend. Double chest bump. And if you did not get the homework done, leave a comment down below. I folded up like a cheap Walmart lawn chair. Now, hopefully most of you guys were able to do it because it was a pretty straightforward extension of what I had done in lesson number 75, where we were controlling the brightness of the red channel of the LED on the Arduino by creating a sine wave in PyQt and plotting that sine wave in PyQt and then passing the data points one by one over to the Arduino over Wi-Fi using UDP and then applying that brightness to the LED. And so that worked pretty good. Then what your homework assignment was to create a green channel and a blue channel and have those three channels equally spaced in time. And then with that, what you could very easily do with that then is create that rainbow pattern on the RGB LED, sort of like an HSV color wheel that you're just going around the outside of the color wheel. Okay, sound good? I hope it does. Let's jump over here and look at the circuit just to make sure we are hooked up the same. And I better get out of your way. I've got under here an RGB LED. This is really kind of covering everything up, a little diffuser on there. Then I have three 1000 ohm resistors going between the red channel, the green channel, and the blue channel. And then the red leg is connected to pin 10 or pin 9. The green leg is connected to pin 10, and then the blue leg is connected to pin 11. So we just go red, green, blue. We go pin 9, 10, and 11. Easy. So we're going to start by going to the most excellent www.toptechboy.com, and then you're going to search and go to a lesson called Controlling Brightness of Arduino LED Remotely Using PyQt and Wi-Fi, something like that, using the happy little search icon here. And I'm sorry I didn't have this called up immediately like I should have. You use this little search icon, search on something like Controlling Brightness of Arduino LED Remotely Using PyQt and Wi-Fi. You'll come to this lesson. I've got a schematic, and then this is the server code that we developed last week. So we're going to copy that. And then also remember, you have to create that secrets.h tab that we talked about ad nauseum, and you have to put your Wi-Fi name and your password, your Wi-Fi password, and then you do that as a new tab on your little Arduino IDE. So we're going to come over here to the Arduino IDE, and let's see here. I think we'll just do it on this one. This looks pretty good. And what you can see is I've already set up my secrets file because I don't particularly want to share with the world my password credentials. So then I've got here the that code that we ended up with last week, and it is all ready for us to adjust. Now, really, What we're just going to do here is we had set up a red pin as 10. Well, we're also going to need a green pin, or it's 9. The red pin was 9, and then the green pin is going to be pin 10, and then the blue pin is going to be blue pin is going to be pin 11, like that. And then we've got that set up. Now we got to do our other pin modes. I think I will just copy this pin mode, and then we will paste that pin mode, and we will paste it, and we're going to go right down the line. Red pin is output, green pin is output, and blue pin is output. Now the only thing that's really going to change here is you can see that we split the string up with our function, and then we write the 0th element. There's only one element, so there's only going to be the 0th element. But what we're going to do now is we're going to take this, and we're going to have on the client side, we're going to send 3 numbers. And so we're going to take that split, and we are going to paste that. Let's go ahead and paste that twice. Okay, so we're going to analog write the red pin, we're going to analog write the green pin, and we are going to analog write the blue pin. The red is in the 0th element of the array, the green is going to be in the 1 element of the array, and the blue is going to be at an index of 2 in the array. And so that on the server side should really be what we need to do. Now nothing's going to happen here, but I'm just going to download it, making sure I didn't make some silly little mistake in the little 6 lines of code I edited there. Okay, it looks like it's connected. Let me just hit the reset button, and yeah, we've got the thing connected, and we make note of the IT address. We make note of the IP address here, and then we will we make note of the IP address here, and then we'll use that over on the client side. Okay, so that was kind of irrelevant there. I guess you can go back and read my WhatsApp messages if you're really that interested in them. But let's come over here now and let's get the client code, okay? And the client code is on the same page. It is controlling brightness of Arduino LED remotely using PyQt and Wi-Fi. So then we've already got the server. We're going to come and get the client code that we started with last week. And then I am going to fire up my Thonny over here, fire up Thonny, and we're going to paste that code that we had from last week. Now, really, it's just instead of doing the red, we're now going to also do the green and the blue. So we just got to sort of start at the top and see where we did that kind of stuff. And all of it's going to have a period of 5, a frequency of that. All of that should be the same. But where we have red data, we are going to also have green data, and that's going to be equal to 0 times num points, and then this is going to be blue data. And I like to spread these out a little bit. Not spread it out like that. Spread it out like that. Okay, and then blue data is going to be, I guess I should just paste that too. Control V. Man, that was a huge mistake, wasn't it? Let me undo. I think I pasted the whole thing. Okay, let me just type it in. Blue data is equal to, we're going to put a 0 in, and then how many times num points, like that. Okay, so we've got green data, blue data, we've got red data, green data, blue data. That all looks good. I did some crazy things there, so I'm just going to run it to make sure that, yeah, okay, so I've got the red showing like it should. Now we're going to come down here, and where we say this is just setting up the overall graph window, and so we don't need to add anything to that. But here where we created the red data, okay, where we created the red data array, we're going to need to what? We're going to need to create a green data array, and we're going to need to create a blue data array. So let's tab those over. So where I have red, I'm going to have red, now green, and now blue, like that. And then these are going to be, now this is where the real magic happens. If I did this right now, I would have 3 sine waves on top of each other. I want to offset them evenly. Now what you got to think about is you have 1 period. And now I want to have 3 sine waves with that same period, but equally spaced off in time. Equally spaced off in what? In the period. So in the period, I want to have 3 equally spaced sine waves. So one, I'm not going to move at all. The next one, I need to move the time by how much? By the period. If I moved it by the period, it would show up. If I moved green by the period, it would again show up on top of red because I moved it 1 period. If I moved it period divided by 2, you would have this one, and then you would be offset to the middle, but then you couldn't evenly space the third one. So I need to I need to shift each one by period divided by 3. So this is, I'm shifting this one 0 periods over 3, this one 1 periods over 3, and then what would this one be? I would shift this one by what? 2 periods over 3, like that. And that really should generate those 3 evenly spaced sine waves, if I'm thinking about this right, and if I haven't made a mistake, like leave a parentheses off or something. Man, get up there, you aggravating thing. Okay, I think that's going to be right. Okay, now I create the actual red plot itself. Well, if I create a red plot, I'm also going to need to create a green plot and a blue plot. So I'm again going to go red, green, blue, and then I am over here going to go, this is R, this one's going to be G, and this one's going to be B for blue, and then I've got to name them. The first one's named red, the next one's named green, and the next one's named blue. And these are the words that'll go on the legend, right? When we have the legend up there with the little line saying what is what, we're going to have red and green and blue. Now here I'm generating the R signal itself. Well, if I'm generating an R signal, what had I better also generate? A green signal and also a what? Blue signal. So this is going to be G and this is going to be B. And we've got to offset these again, right? We offset the green by what? Minus period over 3. Okay. And don't forget to close that. And then this one is going to be shifted by minus 2 time period over 3. Okay, now the cool thing is when you subtract, you actually shift the graph to the right. So when you subtract from the independent variable, which is time, when you subtract that by period over 3, it's going to move the graph to the right by period over 3. If you don't believe me, try it, and if you don't understand it, think about it a little while. Then I have the red right value. I'm also going to need the what? I am going to need the green right, and I am going to need the blue right. So I'm going to have red right, green right, and blue right. You know what the hardest thing is you're going in and cutting and pasting and editing is that one little place where you forgot to change something, and then that can be very, very difficult to find where that is. Now, where I send my data, I'm sending the string of red right. Well, I'm also going to want to send green right and blue right, and I need a colon between those. So we got to do some series concatenation here. So I've got the string value of red right, and now I'm going to concatenate that with a colon, and then I'm going to concatenate that with the string value of green right. And then what do I need? I am going to need another colon like that. And then what am I going to need? I'm going to need the string value of blue right. And you don't have a n colon on it. So that should do it. That should do it. I don't care. I just want to make sure I don't have a silly error in here. So I'm going to try to run it. Okay, that is kind of crazy. That is kind of crazy, but I did get red, green, blue. They weren't really shifted. Well, probably they started out shifted, but then when we got over here, wonder what happened. Green right, red right. RGB. I think it's going to work. We just got to put some more stuff in here. We just got to put some more stuff in here. So this is t minus period over 3 and t minus 2 times period over 3. Let's make sure that's what t minus period over 3, t minus 2 period over 3, red data, green data, blue data, and then I've got RGB, and then I've got the red right, green right, blue right, and then I have my data. I've got my data.encode, then I send it. Okay, now here what I have is I have red data. I've got to now put the data in the arrays, right? Okay, I got to put the data in the arrays. This is where we shift in the red data. We shift all the data points to the left, and so we're going to need to do that for the other arrays as well. And so this is going to be green data, and then we're going to need to do it for blue as well. Blue data. I'm a little disturbed still why that did what it did, but you see we didn't really put the data in the array, and so maybe that was why it was a little bit surprising. Now we got to put that in data point in, that last data point that we got, and we did it for red, and now we're going to need to do it for green, and then we're going to need it to do it for blue, RGB, red, green, and blue. Okay, now this nonsense is just finding what the period is, and the period's the same on all of them. So the period is the period, so I don't need to do this anywhere else. Okay, I'm kind of afraid to do this because I'm just not sure what's going to happen. Okay, why are we getting something crazy like that? I think on that graph, I think on the graphing, when I created the graphs, you know, the red plot, the green plot, and the blue plot, this is that error I was saying. I said red data, where I needed green data and blue data. I know you guys don't like lessons that are long, and so I'm trying to move at a pretty good pace here. But I went a little bit too fast on that one. So let's see what we get here. Let's run it. Okay, boom, but something is not right. It starts out looking good, but then the thing is really doing something crazy. It's like something, the red, the green and the blue are not moving forward in time, which is kind of strange. The green and the blue are not moving forward in time. Okay, so why would the green and the blue not be moving forward in time? Time should be the same for all of them. So I've got green data, I've got blue data, I've got time data. Num points of red data is num points minus 1 is R. Green data, num points, time data. Red plot, you got to set the data here for each one of them. So when you want it to update, you have to change the data that it is plotting, and that is what I did not do. I hope this was what the problem was. So I'm going to have the green plot, and I'm going to have the blue plot, and I'm going to update those with the new green data and the new blue data like that. Okay, now let's run it. Okay, now what do we have there? We have three like really perfectly, we've got three really perfectly, you know, spaced out sine waves with red and green and blue. Now, what's the one thing that's a little bit of an issue? As we've added these new things into this function, we've tripled the amount of work that is being done in that loop, and it looks like the period is no longer keeping up, because now that we've added all that work, it's operating slower than the real-time clock, and so we are doing too many points. And so how we said the magic point seemed to be about 100, well, the magic point doesn't seem to be 100 anymore. So let's take this down to 400. Let's say if we go down to 400 points in 5 seconds, that would be like 80 points. Let's see if that keeps up. If we're doing 80 points a second, or 80 times through the loop a second, that says 5.3. That's a lot closer. Okay. And then let's see 5.1. I think that it would be good to do 75. So what is 75 times 5? I'm not going to try to do that in my head. Although some of you could. You just do it, 375. You don't want to do head math live on the internet, is what I found. Let's do 375. I want to get it a little bit closer to the 5 hertz. I mean the period of 5 seconds, which would be 0.2 hertz. 5.32, 4.97. Okay, so you see now it is getting all of that work done in the time that it has. And so the real time, the update is occurring with the real-time clock in the real world. So that looks good. All right, now what the real question is that I am going to stop this. The program is running, which is a great thing. So we're going to come over here, and we're now going to see if this thing goes through the RGB color wheel. Okay, I mean, if it goes through the HSV color wheel by kind of taking the color of the LED through the rainbow. And so I'm going to start this, and all eyes on the here. Okay, man, look at that. It's red. The green is coming up. It's going to blue. It's going back to red. It's going to green, and it's going to blue. And so, man, I wish you could see it. It is absolutely gorgeous. It's absolutely gorgeous. It's just, as you all know that have tried to post homework solutions, you know that it's hard to post homework solutions when you're trying to film the RGB LED, because the camera just doesn't seem to want to capture it. I'm going to see, I don't know, what if we went to 20? Would it still keep up the way that we think it should? And then what I want to do is, okay, yeah, that's going slower. And I just want to be able to look at that rainbow effect a little better. And okay, yeah, the red is up there now. You see it's turning green dominant, and then green is dominating, but now blue is coming up. So the blue is becoming more dominant as the green dies. And now as the red comes up, we should begin to see purple. We're seeing those magentas and purples that are going on towards red. And so I think we have this done. Okay, the purpose of this homework was just to get you more comfortable with doing math and with doing things on the client side and doing things on the server side, and being able to get those two programs working well together. So let me give you kind of a simple homework assignment for next week. And what I want you to do is go back to www.toptechboy.com, and what I want you to do is I want you to find the lesson. Let's see, I want you to find the lesson that is called Portable Arduino Weather Station Project. Okay, Portable Arduino Weather Station Project. All right, Portable Arduino Weather Station Project. And here is the schematic, right? This is a project that we already did. Maybe you saved the project, but what your homework for next week is go back and build this circuit again, okay? And then get it running with this code. Go in, kind of look at the code, see what's going on. This is just simply a standalone project where there's no Wi-Fi involved. It's just displaying the weather on this little OLED screen. Well, we're going to keep that and go back to where we were. But now you can imagine that this is our measurement unit that will be sitting somewhere. And then what we're going to want to do is build a widget, a PyQt widget over on a PyQt widget over on the Python side, so that from our desktop or from our computers we can sit and we can look at the weather even if we're not sitting there looking at the little measurement unit itself. I hope that makes sense. And guys, I hope you're enjoying taking this class as much as I am making it. It's at this point that I always give a big shout out to my Patreon supporters. It is the support of the Patreons that allows me to keep continuing to produce quality content every single week. So a big thank you to you guys. You can also help the channel by giving it a thumbs up on this video and leaving a comment down below. That'll help me with the old YouTube juice. If you haven't already, subscribe to the channel, and when you do, make sure you ring that bell so you'll get notification when future lessons drop. And as always, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.